Hi everyone, my name is King IV, and this is an AML workshop using IDEA. And in this case, we have a sample politically exposed persons listing, and as well a list of accounts. And what we want to do here is risk rank the accounts to see which ones are highest risk, and we should be monitoring. So I have the data set here. So I have the list of accounts here. I have information like address, name, number, and then I have this address information that has various information here. First thing I'm going to do here is I'm going to filter this table. I'm going to use direct extract to get rid of any ones that has a blank address one. I'll go non-blank address, and I'm going to use this is blank function. I'm going to use address one, make it equal to equal to 0, which means that it's not blank. Oh, I put the criteria in the wrong area, and that'll just reduce the size of this list, so it'll make it a little easier for our analysis. Because there could be many matches, instead of just doing a regular join, I'm going to do a many-to-many join using the visual connector. So I'm going to grab this list and I'm going to join countries together. Perfect. And then I'm going to press OK. I'm going to do matches only, and I'm going to call this account with PEP listing country join. The reason why I'm doing it on country is that I want to be able to do some fuzzy matching, some fuzzy logic to be able to allow us to connect these two data sets. So this will be a much bigger data set. You'll see here we combined 806 and 10,000, we resulted 236. So now what I want to do here is I want to compare the two address information, in this case address one and address. So let's create a new field. I'm going to do that in two ways. I'm going to go street number match, and all I'm going to do here is I'm going to check whether or not the numbers in the address information are the same. So I'm going to use just numbers. I do address is equal to just numbers address 1. It's going to be a 1 if they are a match, and it's going to be a 0. So I obviously imagine that there's going to be many ones that are not going to be 0. So so again, 1 is a match, which means the numbers are the same. So if we look here, 1895 is the only numbers here. If I check here, 1895 is the number here. But you can see pretty clearly they are not the same address. So that's why we have to do this. We'll do the letters match, or we'll do letter scoring. So what we're going to do here is we're going to do a calculation. So we're going to use this function called similar phrase. So if you don't know this function, it's actually a pretty useful function. So let's see if we can go down here. What it'll basically do is take a look at the two phrases and then compare them to see and give them a score between 0 and 1 to see how similar they are. So in this case, what we want to do is we want to use just letters, and we want to then look at address, and then just use just letters again, and use address 1, which will be from the politically exposed persons list. If we evaluate, you can see here it's 9% similar. We're going to leave to 2 decimal places. And I'm just going to quickly, I might have to index this one again because it usually does default ascending. But we're going to take a look at it in a little bit. Okay, so now you can see here, there's ones that are exactly the same, and then some of them that drops off pretty quickly. So we can probably isolate for these ones, but even if the numbers don't match, they might be interesting as well. So you can see a couple of these where the numbers don't match, but the letters are very similar. So it might still be something to look at, right? Because there might be other considerations to put into place. So anyways, that's analyzing with addresses. So now next thing we're going to do here is I want to compare names between these two lists to see whether or not there's any similar names. But if I combine this very large list, 129,000, with this 806, it's going to be a very large listing. And I got to figure out what's the most effective way to match it on. In this case, what I'm going to do here is normally I would result in a larger join, but this is kind of a large, it's going to create like a large file. It'll probably be a couple gigs. It might be a little slow for me to run on my desktop. So what I'm going to do here is I'm going to create this first letter, character 1. And all I'm going to do here is I'm going to use this left function, take the name. I want to just take the first letter. And I'm going to do the same thing on this other table. Use the same function. I'm going to call this first letter, character 1, and now I'm going to join based off of that. So I'm going to do visual connector. I could filter down this list because I know for some of them they don't have the names, but I'm just going to leave that here. I'm going to uncheck some of these columns just to make it a little easier, because all I really need is the names and then the IDs to be able to bring these two listings back together. Okay, and this should hopefully reduce the size of, and actually don't need these first letters once I join them. And we'll call this account pep name join. And what this will do is it'll show me every combination of where the first letter of the names match. And you'll see it here. Oh, okay. Let me just, so you'll see here, there's going to be a lot of false positives in this, but let's try to create a field. And what I'm going to do here is I'm going to go name match score, and we're going to use a similar function to what we had done previously. I am going to slightly modify it, similar phrase. I'm going to use the all trim function just in case it doesn't trim it. I actually think it might already trim it, and I'm going to use this upper function just so that there's no confusion there. And I'm going to grab that function here, and then I'm going to put it as 1. So now, okay, invalid parameters. I got to put a bracket here, comma, nope, put comma here. Okay, I'm missing another bracket. Okay, perfect. And you can see this table is actually, what, 5 million rows? It's a little bit, hopefully it's not too big. It's about a gig size. And then if we sort this, I'm going to have to sort this twice. But this will give us an idea of what kind of, how similar the names are. So I'm gonna cancel this, and then I'm going to create a sorted table using the name score, and I'm going to call this account pep name join sorted, and I'm going to sort descending. Delete this key. You see, when you navigate with these larger of a tables, it can be a little bit challenging, especially if you run it locally. Obviously, a lot of times if you want to run these higher power calculations, and you'd run on a server or a computer with more processing power. Okay, so now you can see here we have it sorted. We have a number of different matches. So you can see here some of them are exact. Let's go down to the less exact ones because those are easier to spot. So there's a couple of them that are 94%. You'll see here Thomas Bailey, Tom Bailey, and then you'll see here they're starting to catch some false positives. You'll see here that these actually ones are very similar, but obviously, so you have to take into consideration. You can also do this additional function. I'm not sure how effective it will be here, but we will check. So we'll go name sounds like match, and what we're going to do here is we're going to use this sounds like, and we're going to do upper name at upper name 1, and we'll close it off, and then it should give us a 1 or 0 to tell us whether or not they sound alike. And obviously this is not perfect either, but you can apply these. Obviously these look like they sound pretty similar, but you can take a look here and see whether or not there's any other interesting ones that you might want to dive into. So when you're dealing with these like unstructured type information, unstructured data like names, then obviously you have to, it's not going to be perfect, but it is going to be useful and allow you to focus your analysis instead of reviewing all 129,000 names to see whether or not it matches with the 806. Arbitrarily, you can actually do some analysis. So ideally what you would do here is you would put these two analyses together, perform a risk ranking, tell me why you developed that risk ranking, and then go out and investigate from there. But I'll leave it there. If you have any questions or comments, feel free to leave it in the comment section below, and I look forward to speaking to you next time. Thank you.